So this is the third of 3 videos going over our review of grade 9 chemistry. Some of these ideas also should be familiar from elementary school, I want to say. Okay, so we're going to talk about now properties. So chemical properties are basically what we describe when a particular substance changes into some kind of a new substance. Okay, so a chemical property describes that particular behavior. So students have trouble with understanding chemical property, so I'm going to juxtapose it with something else here in a second. So for example, we would say that a chemical behavior, a chemical property of sodium metal is that it reacts violently with water. So, notice that I'm talking about how it reacts in becoming a new substance, right? So we take sodium metal and we react it with water, and so that describes a chemical property of sodium metal, okay? As opposed to a physical property. So a physical property of sodium metal is that, basically we're not looking about how it interacts with anything else or how it changes to be something else. We're just talking about its description as it is. Okay, so how could we describe sodium metal? Well, we could say, well, it's soft. It's lustrous, right? I'm cutting through it. I can see that it's soft. I can see it's got that shiny luster, and it's highly malleable. Okay, I'm not describing how it becomes anything else. I'm just describing it as it is on its own. All right. So chemical property, when something is, how it behaves when it's changing into something new. Physical property just describes it as it is. And so there should be a link in our week plan with some physical properties that you probably saw in grade 9, such as like malleability, ductility, clarity, texture, and so on and so forth. So good idea for you to review those ideas, specifically if you're taking grade 11 chemistry. That's going to be important for you. So let's talk about chemical change. Okay, so chemical change describes a change in a substance where we're actually forming a new substance entirely. Okay, so we would say that, when you fry an egg, that is a chemical change. Okay, we're going to talk next about how, what are some indicators of chemical change, but we know that this is a new substance when we fry that egg because it doesn't have the same properties as it had before. Okay, and we also, how do you uncook an egg, right? So that is a difficult change to undo. Okay, so signs of a chemical change. I want you to stop and think about ideas from grade 9 science, that help you to identify whether a chemical change has taken place. So first of all, change in odor for sure, right? So think rotten egg. So that egg, before it becomes rotten, has a particular odor. And then as it degrades, okay, rotting egg is a chemical change, right? The egg becoming rotten changes it. And we know that it's a different substance because it has a very different odor to what it would have had previously. So change in color. So a change in color indicates a chemical change. So for instance, here I have this solution that when I pour this pink solution in, changes to a variety of other colors. First purple, and then blue, and so on. And there's no real explanation for that color change except for there to be a new substance present. Hopefully that was on your list. Okay. Next, we have the formation of a gas. So when I combine, let's say for instance, a metal with some hydrochloric acid, I often get hydrogen gas. And that gas wasn't there before, and there's no other explanation for it, right? So I'm not heating this solution to create little bubbles. I added little metal pieces to this, and those metal pieces are reacting and forming a hydrogen gas, right? Okay, next. An energy change. Hopefully that was on your list. Like, maybe there is some heat that evolves, or maybe the temperature goes down. Okay, maybe there is light that is produced, or sound, right? So, sound in an explosion is a good indication of that there is a new substance formed. One example that I use in class often is I take this magnesium ribbon. And magnesium ribbon has this property: when you add some heat to it, when you heat it on a Bunsen burner, then it creates this nice sort of glowiness, which you can see there, right? So in class, I would normally be doing this. I would take that magnesium and I would light it up, and it creates this nice bright light. And that is indicating to me that I'm creating something new. Okay. Lastly is this thing called a formation of a precipitate. And this is the one that students tend to forget about, because that word precipitate, is a little bit of a sciencey word, but let's go through that. It becomes really important in grade 11. So I have two solutions here, and notice that these two solutions are both clear and colorless. Okay, there's a black background. Okay, and I want to differentiate between clear and colorless, because sometimes I will ask students, well, what's the color? And they will say it's clear, but clear just describes the transparency. Okay, I can see through it, it is clear. Colorless describes the absence of color. So for instance, cranberry juice, I might describe as being clear because I can see through it, but it's also red in color. Okay, so now I have these two clear, colorless solutions that I'm going to combine. And when I combine them, I create a solid, right? And that solid eventually becomes heavy and it sinks to the bottom. And there's no explanation for that solid coming from those two clear, colorless solutions. Okay, and so notice that the color of the transparency has also changed to opaque, right? So when you take two clear solutions and you combine them to create something that becomes opaque, something I can't see through, that usually indicates that a precipitate has formed. And that precipitate will eventually sink to the bottom because it's a little heavier. We're going to look at that in another bit that we do a little bit later on. Okay, so a physical change as opposed to a chemical change is one where we're not creating anything new. We're just changing the form of the substance that we have into a different form, but it's still the same substance. For example, if we melt ice, right? Well, ice has water molecules in it, and so does liquid water. So does water vapor. Right, so any change of state from between liquid, solid, and gas, if we have the same substance, then is a physical change, not a chemical change, right? Grinding coffee. So if I were to take solid coffee beans, that is a change in texture, but I still have coffee. There's no new substance being created here. And lastly, and this is the one that students forget about, which is dissolving. Okay, so if I dissolve salt in water, I still have salt just dissolved in water. Let's talk a little bit more about each of these physical changes. Okay, so again, we see this ice melting. Whether I have water in solid form or water in liquid form, I still have water. There's no new substance there. Okay, if I take my coffee beans and I grind them into coffee, I've just changed the texture, but I haven't created anything new. It's still just coffee. And lastly, the dissolving one. And again, students struggle with this a little bit more, but I'm going to try to explain it. This is an example of something that I can easily reverse. All I have here is just salt dissolved in water. It's not anything new that's magically happened. And I can easily get that salt back by just, evaporating out the water and collecting the water separately. And that salt would remain. So now there are a few caveats to identifying these chemical and physical changes. Okay, we have to be cautious, right? There are some examples where we just have to use our noggin a little bit and think about common sense. Ultimately, at the end of the day, we want to know, has a new substance been created or not? And that is really what differentiates a chemical change from a physical change. Okay, so, here's an example where I've got water boiling in a pot on a stove. Now, of course, when I boil water, I'm just taking liquid water and I'm evaporating it, right? So those bubbles of gas that are there are not a new substance. It's just the water that is changing state. So there's no new substance that's formed there. Okay, so be careful about gas bubbles as indicating chemical change. In this case, there's no chemical change. Okay, just a change of state. Okay, now dissolving. Now imagine that I had, Kool-Aid crystals, in a jar, and I simply added them to water, right? Is that color change the result of a new substance being formed? No, I've just dissolved. Okay, so when I dissolve drink crystals like Kool-Aid into water, that's just a dissolving. I can easily get back my Kool-Aid crystals by evaporating into the water. So there's no real new substance being created. Okay, lastly, I want you to imagine that I have salt, and this person's just adding salt to water. And you can imagine that person could be adding salt to water to a point where they've added so much salt that no more of that salt can dissolve. Okay, now remember, dissolving is a physical change because I haven't made a new substance. Okay, so in this case, the solid that forms in the bottom here, okay, that won't dissolve is not we can say it's a precipitate, but it's not really a sign of a chemical change. Okay, so not all precipitates are indicating a chemical change has occurred. In this case, we've just added so much salt to that solution that no more is going to dissolve. So yes, it's a precipitate, but no, it's not a sign of a chemical change. Okay, so again, just to remind you, at the end of the day, that not all changes where we see those signs of a chemical change necessarily are a chemical change. At the end of the day, we need to remember that a new substance must be formed for a chemical change to have occurred. Okay, so at this point, you're ready to do the last little bit of our chemistry review worksheet. Work through questions 8 and 9, and then you should be done. Just reminding you that there is a quiz tomorrow on chemistry review. So very important for you to reach out with any questions that you have or any extra help that you need to practice this before tomorrow's quiz, and more importantly, before we move on to the next topics in our chemistry unit.